Welcome to Monobiology. Today we're going to talk about classification in biology. And we're going to look at some of the systems that are in place, and I'm going to introduce you, talk about a little bit of the history, introduce you to this guy here, who's kind of hiding. Come on out, Carl. There you go. There's Carl Linnaeus. Carolus Linnaeus is his Latin name. And he is essentially the father of modern taxonomy. There he is, the handsome devil. So basically, folks, taxonomy is the science of classifying organisms. We use if you're Sheldon Cooper from The Big Bang Theory, then it would be a very soft science, but it's the science of classifying organisms. And it has two purposes. Obviously, we want to identify organisms, but also we want to represent the relationships among the organisms that live on planet Earth. So it's a noble goal. And this gentleman right here, Carolus Linnaeus, was not the first person to come up with a system, but he's the person who came up with the system that we currently use. Okay, so let's talk about that system a little bit. First of all, and you should already be familiar with this a little bit, but we organize our organisms, into three domains. And those domains are archaea, bacteria, and eukarya. Okay? Now, these two domains here are all bacteria. All of them. These are all of the prokaryotic organisms that live on our planet, right here. This domain here houses everything else. Okay? Alright, so like I said, the first domain, which is right here, the first two domains, the bacterial domains, the archaea and the bacteria, are the first two kingdoms. We work on a 6-kingdom system. Eubacteria, archaea bacteria, and these are the eukarya domain: Protista, Plantae, Animalia, and fungi. Okay? So Linnaeus didn't come up with this system, but he came up with the system that led us to develop this. Let me show you. So even though Linnaeus didn't come up with the entire system you see here, the work that he did led to this system. What he did come up with was the two-name system of naming, the genus-species system of naming, that we now refer to as binomial nomenclature. And binomial nomenclature quite literally means the two-named system of naming, the genus-species system of naming. Okay, so just really quickly have a look here. We've got humans, Homo sapien, ostrich, Struthio, camelus. What do you notice about these? You should notice that the names are all italicized. Okay, so scientific names will always be in italics or underlined. If you're writing handwritten, you probably don't want to italicize. Underlining's fine. The genus name is always capitalized. The species name is always written in lowercase. Okay, so Homo sapien, if you were writing it, you'd underline both of those. Or if you were typing it, you'd have it in italics, genus, species. So it goes kingdom, phylum, class, order, family, genus, species. And again, this is all based on the work that Linnaeus did. All based on the work that Linnaeus did. Now, binomial nomenclature, the system of naming that Linnaeus started, is all derived from Latin and Greek words. So all of these words that you see here in this chart are all Greek or Latin terms. Now, why is that? Why would we base our system of naming on those two languages? First of all, the languages, especially Latin, are dead, which means they don't change. And that means the meaning of the words, which is very important, will always stay the same, no matter if it's 2000, 2015, or 2150. Because it's a dead language, the words will always mean the same thing. There's no way for those words to change meaning. The second most important reason why we use Latin and Greek is because it's universal. So in other words, if I speak Japanese versus English, I will always be able to understand that Homo sapien, of course this is assuming that I'm a scientist, Homo sapien is the scientific language, and it means human. So whether I speak Italian, Japanese, Greek, whatever, I will understand that the word Homo sapien or the words Homo sapien refer to humans, if I'm a scientist. Universal. Everybody can understand it. Now, this is all hunky-dory. This is the system we use to name things. You can see two examples here. Here's humans and ostriches. Every living thing would fit into a category this way, in theory, but there are problems with the system. The two biggest problems with the system. What? My system does not have any problems. The organisms, there are organisms that don't seem to fit at all. Or there are some organisms that try and fit into more than, or that are capable of fitting into more than one group. Both of these issues are problems, and the reason they're problems is because this is a system that humans have developed. There's no such thing as a perfect system. You're always going to have outliers and things that won't fit perfectly in. Okay? This one here, organisms don't fit properly. That means we're trying to take a square peg and fit it into a round hole. Not going to work very well. Organisms fit into more than one group. Where do you put them? I don't know. What I do. Anyway, the system works for a large majority of the organisms, but there are some questions left, and it's an imperfect system. Now, here's an example. See this guy here? See this guy, Carl? This guy here is a protist. It's a euglena. E-U-G-L-E-N-A, euglena. And basically, it is strange because it is an organism that can make its own food, but it is also an organism that moves. It has traits of both a plant cell, chloroplasts, and an animal cell, a flagellum, which you may or may not be able to see over here. In this area here, there's a flagellum. Flagellum there, sorry. It's labeled, so there it is. Anyway, so chew on that, Carl. And that in a nutshell is both the modern taxonomy and the problems with it.